So hi everyone, I think we are live. Welcome back to the series of building a production RAG system for NASA documents. Currently we're dealing with 10,000 plus documents, and the system can actually scale beyond 85,000. Beyond a system, this system could even scale to beyond 100,000 documents. And these documents are very complex, um, filled with a lot of technical jargons, diagrams, formulas, and whatnot. Scanned copies from 1960s to one of the oldest documents we were dealing with was from 1951. So essentially, we're dealing with documents that range from 1950s to 2025. Yeah, so all of the documents we're working with right now is pulled in from NTRS, from NASA's technical server, which is totally free. You guys can go ahead and grab. You have a limit of the number of documents you can pull in for a minute or something, but you can access everything is free. Even if you want to download like a million docs, you can go ahead and do so. Everything is free. So let's quickly recap on what we're doing. This is actually, the final day of polishing. We've completed most of the important stuff, and we're in our final phase of, final day of changes, to be honest. Let's go through what we've done so far and what we're doing today. And I think this will be like a, full-fledged stream where we kick off everything, the final changes, and get everything polished in a single go. Right, so let's look at what we started to work on for a fictional company called Meridian Aerospace. It's a mid-sized aerospace engineering consultancy. Yeah, so they basically essentially they work with a lot of technical analysis, safety certifications, safe satellite propulsion systems. They work with government, space agencies, and commercial launch providers. That's the scope of it. And they have about 85,000 documents. Some of them are from 1950s. I would actually update to 1950s because we're dealing with 1950s documents and the modern digital reports. Engineers currently spend 4 to 6 hours per project searching for stuff and everything they missed, blah blah blah, on all of the stuff. And the whole goal is to help them find the right documents in the archive of 100,000 documents in a given space, and also basically supercharge them, being able to identify many things across many different documents, search things up they wouldn't have found if they would have searched through or spent a lot of hours, because each and every day engineers spend a lot of time in diagrams, analyzing formulas, analyzing content, and etc, analyzing diagrams and like images, figures, and etc. So we've designed this. In fact, I want to show you. I'll actually write a blog post on how I did the document processing for this. But you can see this is how one of a clean document would look like, and this is from the 1960s. They have a lot of formulas. They have formulas inside the table, and we spent 3 to 4 days, entire 10-hour live streams a day, solving this problem. So we basically build a very tight document processing system that can accurately parse tables, that can accurately parse formulas. And this is not a naive chunking. We're not doing basic chunking. We're doing such a systematic chunking. We have custom pipelines for diagrams. We have custom pipelines for formulas. We have custom pipelines for mathematical equations, figures. And we also remove a lot of noise like the classified information, unclassified as black spots, and etc., and turn them into such an accurate, clean model. And all of this document processing is run by, we're using docklink for it, for layout detection, and then we're using open source models. In our case, we're using the 7 billion parameter model to run it. To quickly show you what we've done so far, let's see. I'll show you the amount of documents we have right now. And yeah, so hopefully let me just zoom in, maybe if you can see it. So you can see we ran it. We have one H100, and this itself is a different sort of thing to pull in terms of infra side. We processed this in about 2 days. We ran it on the GPUs, and we processed about we processed 10,000 documents. Around 20% of the documents did fail, and we have about 8,608 documents, and I'll also retry the other 2,000 documents as well. And if I were to show you Qdrant, you can see that we have about 1,000,000 chunks, so 1,000,000 points, right? So this is the scale we're dealing with, and to solve this at scale itself just took us probably a week, like, to figure out. We just pulled off a super complex part. We just stripped out each and every package. We had a CPU layer, we have a GPU layer, we had parallel processing, we had services, we have watchdogs, and it is such a, I would say, such challenging part to build this, because you have to process 10,000 documents at scale, and we're using the 7 billion parameter version model as well, which only one H100 GPU. How do you solve it, and how do you efficiently use that? And we did it on FP8, so used H100 to the optimal potential. And yeah, and then we are here. In fact, Qdrant for some reason restarted, and I lost all of the million chunks, and I should have processed it today. I was there, I was out for an event for a couple of days, probably like a week. I didn't upload because I was busy with something. And yeah, Qdrant for some reason, I'm not sure what, restarted. Probably lost everything, but luckily I did make a snapshot before I leave, which essentially saved me. So we are back again, without the need to reprocess stuff. Okay, so yeah, this is an example of a amount of documents we deal with, and that's right now in Qdrant about 8,000, around 9,000 documents like this. Right, so this UI UC is the agent. We also spent like 3 to 4 days designing the agent, an agent that is as smart as a human researcher. We're spiking the domain intuition. It's such a clean way of designing an agent. It has a lot of tools like checking the sections, getting specific chunks, going up and below a document, taking snapshots of an image, and also launching sub agents as well, a research thread like Cloud Code, and doing parallel research and parallel hits, and yeah, much more really. And domain terminologies, because we also solved domain terminologies. In fact, we had about 18,000, I would say 18,000 words like jargons, and usually I fine tune a model. So this case we're using Claude, so because of that I didn't fine tune a model, and I added it as a tool. But the overall idea is that we filtered so it's called NASA Thesaurus. I just want to give you like a quick idea on what we did. So I mean, you are aware of what we did in the past few days, past few weeks, I would say. So NASA Thesaurus, oops. So they have about 18,000 jargons, and with synonyms and etc. Because this documents are dense with jargons, we have a tool to call all of them. I could have fine-tuned it, but we are not using an open source model, so because of that I didn't want to, because I'm also very low on compute as well, so I didn't really think about it. I've literally spent like $5,000 a month on an H100 renting it from Azure. I'm done with the credits as well. So yeah, cool. So the idea is that we use the 18,000, and so this has a lot of definitions, not only on aerospace documents, but also life sciences, a lot of medical terms, biological stuff. And so we basically, what we did is that we just took, we filtered, we did some filtering, and for only propulsion specific documents, and we took about 4,000 to 5,000 jargons, and we just, because we didn't want to use 18,000, and we embedded them as well in Qdrant. So that is the current stage we are in. Yeah, so today's goal is to complete the project. There's a lot of moving pieces, a lot of polishing to do, a lot of issues as well. So our goal is to completely get into it and completely just kick it off. Just do all the final polishes, the final changes, and etc., and then wrap it off. So yeah. Let's see if the audio is working. Just the final changes. Okay, the audio is working. All right. All right. So a couple of things. So we've solved. Let me go through the checklist. We've solved for scan copies. We solved technical diagrams. We solved domain acronyms as well. We've done with mathematical equation formulas. We've done with tables, cross references between documents failure. Yes, that's done. That's something that we're doing right now. That's an agent sort of thing. Natural language search system must be understand retrieval technique. Engineers must be able to ask questions like this. And okay, yeah. So the final sort of issues that I see right now is, I'm just polishing this and etc. I have a few things noted down, and I would wanna, as I move on, I also wanna make, add this up and make changes. Now, one of the stupidest thing, one of the most, not the most, but such a stupid thing that I did was that I did not have minimum. I didn't segregate. So usually you do 256 or 512 chunks for each chunk, right? What I did, I relied on Dockling's processing, and we started, and it gave me a lot of chunks, like very small chunks like this. If I were to zoom in, you can see a result 5, and some of them like are sort of headings. So headings are also a chunk, and that's added. So I did give like 150 characters or 150 chunks. 150 tokens was like the minimum, but I should have done 512. So because of that, I'm actually seeing a lot of um yeah, a lot of small text over here. Could you see this? This interpropellant leakage is actually a result 15, which is quite insane in 900,000 chunks. So I think what I should do right now is to sort of fix this and just go back and talk things through whether I can reprocess that. But even if I were to reprocess that, there's like document ordering that we did. The documents are ordered in a such a way it can't be messed up. So all such, yeah, stuff like that, right? So um, I'm just gonna go ahead to Claude and yeah, just go through a lot of things. So I'll be like, so this is good. Now I would like to work on the final changes. One of the things that I note down right now is that because we have been relying on docklinks chunks, or docklinks paragraphs and etc., some of the chunks are actually titles and they're very small. They're just like headings, and I could see that being chunked. So when I do a search, I am, in part of, let's say I'm K15, I only end up with a lot of the text is actually like titles, and which is something that I just don't want to have it. What are the options right now? I know it's my bad, but what are the options we have right now? Could we, I cannot reprocess it, but could we merge the chunks? If then you have to check the entire document processing flow. We have such a you have to check the entire document processing flow because it goes through a lot of moving pieces and then document ordering and etc. to come up to this position. If not, what we can do is um, yeah, do something in Qdrant. I'm not sure, but we have to sort of see what are the options that are actually available. Or if not, what we can do is that we can could we like systematically or in a low level let avoid like let tell Qdrant to avoid chunks that are less than 150 chunks or 300 chunks, or something like that, um uh, which could be not the best case, but just curious to know. um and yeah, I don't want it to do the computation for the chunks that are less than 300 tokens or something. But yeah, these are the sort of the options that I have. Just think through this and let me know. Actually, this should be processed over here because this is where all the document processing and stuff is going on. But we can still add the text filtering option in Quadrant. but that will not be the best case. Like, it's such a naive approach of work on. It is actually my bad. I thought I should focus on this, and in some I was in a hurry to process it, and I just thought, I completed all the parts in processing and just started the process. And if I were to process it again, it'll take another 46 to 50 hours. And in case something goes wrong, then another 30, 40 hours or something if I want to reprocess. So short chunks, like, yeah, you can see these are also chunked. Anyway, there should be a way to figure this out, so we'll do it. I think the best is to merge. We have a snapshot, create another collection, and just merge everything. Yeah, so the entire idea is that, like, we want the embeddings to, sort of give us the relevant chunks for a query, right? And sometimes a chunk that is quite less than 100 characters would be more valuable than a chunk that is actually more than 300 characters, because what we're trying to find here is the most relevant chunk and not the most lengthiest chunk. So we already have a snapshot. Could there be a way? I want you just want to know, but could we accurately merge the chunks? For example, we have the entire document order and we have the entire document. We don't need to reprocess it. What we can do is that we can find all the chunks of a single document, and then what we can do is that just merge the chunks, like merge them. And but there's a tricky part in the ordering, but we need to basically see how, where sometimes it could be very simple as well. The ordering wouldn't be a much of a problem because you're merging the chunks and the ordering becomes the basic ordering. uh, so yeah, curious to know, check on this, check the entire document processing and then come back to me, because I think that's the most, like, that's the only way of using it up to the potential. That's why we use Qdrant, right? That's why we use embeddings. If we were to filter those out, and I don't think that'll be the right idea. So relevancy, yeah, relevance matters more than the length, because here we're working in a space of I don't know, 700, 800,000 tokens, and a small chunk could mean a lot, rather than a big chunk. So we'll see if we can do something on this. Probably yes, that is an option, because we don't need to reprocess this. We can just literally write some code to process, I don't know, what are the documents sequentially or parallelly, because it's just a loop of just getting the text and then merging and save it in Qdrant, getting the text and merging and save it to Qdrant. That's it. Yeah, only text chunks can be merged. These we're not touching tables, pictures, or formulas. The code already merges functions. Yeah, minimum is 150. Mm. Quadrant for all, query Quadrant for all chunks. Find consecutive chunks that are short, merge adjacent chunks, re-embed them only the merged chunks. So these are not big limitations. These are nothing. So yeah, I would say, yeah, this looks good. I would say we already have a snapshot, so we can use a snapshot and create a new collection, and then we do all the work in the new collection. This way, we don't break anything. In case something breaks, we can always fall back to the other collection which we already have. But I'm just out of the top, just out of my mind, I think we also store the section header information and etc. I guess in metadata. I'm not sure how you'll handle section data and section header data, or the metadata um, for this, because the text that is above could actually have a different, could be part of a different section, could be part of something else, and if we were to do 512 chunk split or something like that, there could be some merge, there could be some irrelevant merge. So how do you go through this? Check what metadata we store, and yeah, probably we can figure this out. Not a big deal, to be honest. Okay, so okay, finalization. Actually, we only should touch text and not even go close to tables, picture, or formula. We should never touch the other stuff. I'm only talking about text. Yeah, now the issue is that some of the times the section headings and the titles are itself no, I don't think it will be wrong, because in case we come up with a big title, introduction, and it has 25 paragraph, those 25 paragraphs uh, will be um will be part of that big introduction or whatever the page is. So yeah. Yeah, so some of the times you might not have section headings and section like whatever, like metadata on that as well. If that's the case, how would you handle it? And there could be tables, and there could be tables, there could be figures, everything in middle. Could we do we still keep the proper ordering? Simplify the express. No heading only. What has sense of text transfer? Yeah, this looks good. So yeah, create a snap. Let's say, yeah, looks good. Um, so looks good. Create a snapshot. I mean, create a new collection with the new. I would say snapshot. So create a snapshot, and yeah, create a new collection and proceed with this. And also how much time do you estimate for this? Like in terms of processing the entire thing, because I'm sure we don't need to use any VLM here, and it'll just be, analyzing the lengths of the text and doing whatever you want. So just curious to know how long do you think it'll take for all of the Qdrant chunks? Call it production. Actually, call it merge production. Okay, so we should have the collection here. So we'll verify it. Okay, production merge, same. And I think, yeah. So we can use the GPU here. Not sure what the threshold is. I'll keep it at 512. Actually, before we do it, I want to try 512 for each chunk. I mean, of course, we would try for 512, but sometimes there could be, no, you can't achieve 512, but I want to try to achieve 512. Sometimes you could have tables and all of them in between, then of course you can't do anything about it. But as long as we have good amount of adjacent text and chunks and text chunks, and we keep everything ordering and everything proper, I would like to try with 512. Would 512 be still okay? I mean, we can try to have it. Some of them we would just end up with 200 or 300. It's fine because it can be end of the paragraph, or it can be end of the document, or it can be, a lot of tables and stuff in between where we don't want to confuse the ordering. But wherever we can, we should try to achieve 512. Could that be possible? Okay, so stop merging if the max size is 2000. Yeah, that we won't hit. Maybe we might hit 2000. I want to be the minimum 512 and also maximum around 750 chunks. Like maybe I would want the maximum to be 750 chunks. No, actually we'll leave it at 2000. We'll leave it at 2000. It's fine. Just gonna do a dry run. Results document was 6000. Yeah, it's around 7000. Text chunks before this. Text chunks after. What is this chunks deleted? Are we deleting any chunks? Okay, now run it to the full collection. Maybe give me the command, I'll run it. It is pretty quick. Embeddings are actually, oh, maybe we're not running embedding model, that's why. You run it in Qdrant. You're running it locally. Yeah, actually, delete it and I will restart it again. Oh. Yeah, you can run the restore collection curl. It paused here. It paused here. Or maybe, yeah, okay. Orem is running. Okay. I wasn't watching it. That's okay. is this process okay, or do you want to um, is deleting okay, or do you wanna like put it to a new collection? Is both still the same? Option A is fine. We still have the snapshot. So I think this will take some time. We can maybe use this time to work on something else. Image not visible to our model. Final changes, that's some sources in the UI. Yeah, there's a bit of issue in the sources, so we'll just fix that. All right, we'll just switch tracks a little bit, and we will actually fix some issues in the UI. In sources, I think there's some re-rendering issue. Please check on this. I'll just paste. Please check on those. Yeah, those. Okay. Okay, now it's better. We only have 6. Last the same question. And because we have a lot of chunks, the embedding computation itself will take a lot of time. That's why you can see like 3 4 second 5 second gap. Once this, usually if it's local, you have a few documents, it'll be instant, usually instant. This will take time. We can, I've never, I would just have to see, maybe that's the last thing that we work on, just to see if we can get it to that, closer to that specific second sort of range. This is more than enough for now. You can see, we also have document metadata information and all here. So you can see this is the TOC, table of contents. Everything coming from the not partly docking, partly VLM, and yeah. And you can pull up all the sections there is in introduction. So see, just got the heading section and was able to pull it in. So all of these issues will be fixed once we do the post processing of entire thing. Still, it can still find that the agent is, so there's, two ways of doing it. One, the agent is also strong, document processing is also currently strong. In case we, even if we have a very bad chunking in document processing, the agent will still try to find it. So not a big deal. We're just trying to um, make both efficient. In worst case scenario, one of them should help. That's the overall goal. Okay. There seems to be some issues with the sources. Do you want to save the final response somewhere and check if it's an issue with the response or it's an issue with whatever? Actually, first of all, you should see the raw response. What is the raw response? And then you should see, maybe just put it in the console, grab all, don't stream it, grab all the final response, and then finally put in the console. I will share it with you. Just a raw response. Okay. Actually, restart this for some. Wait, I'm not able to understand. The model gives you sources, and how do you pull those sources in the first place? Like it only gives you IDs, right? How do you get the sources from it? Because I don't remember adding an API for it. Exactly. We just need an API where uh, uh, you can call, or maybe you can call it in a bulk. Sure. Sure. We actually need an API given an chunk ID. You would just retrieve the entire chunk. Simple. But we need an API for it. Yeah, so document ID and chunk order is the unique identifier. Basically, the combination of both is a unique identifier for a specific chunk. We didn't create IDs for each chunk because anyway, document is unique, chunk is the order is unique. You won't have order two. I mean, if it's 11, it'll be 11, not 11.5. So we identify in that way. Changeables. I mean, still nothing strict. There's no big reasons of why I did it. It's just there's one way of uniquely identifying it, and that's enough for now. Get multiple chunks in document. Yeah. So just now it loaded all the sources. So yeah. Good. Um, see the final sources. As for the inline sources, it's coming. Very good job. Because the text could be huge, right? So I want to be able to scroll it inside, you know, because I can see it's a cutoff here. So I should be able to scroll it if needed inside. Upon clicking on this, it should open up a PDF and then it show me. So that is still, um, I'm not sure how to do it, but we'll figure it out. Scrolling it, when I try to scroll it, the sources are actually d- disappearing. Okay, so you can see the huge difference. If I We've almost deleted the 121,597 chunks, essentially noise. So this is good. So retrieval will become better. Yeah. And better and faster. Okay, good. So this is a image, right? So this is processed through a VLM. Now what I need to do here is, let's see. just make the sources inline sources model a little bit, increase the width a bit and increase the height of it a bit. I just want it to be a little bit more expanded. Because I want to see the sources. Right? This is quite small. Yeah, we'll try it now. Okay, this looks big. This is what we want. Good. This is good. Now I want to work on something important. I think this will take easily 1 hour. We could have done it faster, but still let just go on because we still have time to fix this stuff. I think it was easy. Okay, there's another 1 hour left, so it's fine. Cool. Now I want you to perform 3 tool calls, and I would like you to visualize the diagrams. Now we get this error. PDF not found because of course this is my local machine and that is in a VM. So we have to fix that. Basically, I should get a base 64. I should literally get the image, like the return the base 64, and I can render the image here and show it. That's what I want to do. Or I can render open the PDF here if the PDF is exposed. But that's just huge work. For now, I don't want to spend time in it because I need to render the PDF and then check the local file system and etc. But for now, I can get the base 64 here and then show it. We'll actually fork a conversation here. This is the original. We go back to the original when we want, but for now we'll do it. So let's view image. When the agent tries to view an image, it's one of the tool. The agent could view the images. You can check how the agent does it. We have files stored locally, and of course we initially did it through my computer, my Mac, and right now all the files are right now in a VM, which is this VM which you are in right now. I basically want now this is one issue. The agent is not able to view the image because of course it needs to do a lot of work to view the image. We have to fix that, and also we also need a way to send if an image is viewed, or maybe if the agent checks a picture, or there's 2-3 tools that that is related to pictures and figures and tables and etc., which usually works with a lot of images and PNG. If whatever images or PNG that the model sees, I want it to be shown in the UI. So we need to figure out how we have to do it. There's a couple of ways to do it. Do not code. Let's think this through, because it's the entire use case we need to build and not just for sending images. So yeah, check on this and come back with your understanding. I'll paste this and I'll be like, this is what I see. Yeah, actually what I'll do is I'll copy UI. Again, there are a couple of tools. You want to check the code and irrelevant code and tool calls and etc. to get a good understanding, which works with images, figures, and etc. So make sure you do the background work and come back. We will try. So it takes about 41 minutes. Okay. Get these are the two tools which uses images. View chunk image and this within. Oh, maybe I think all the files have been deleted, maybe. Oh, oh. Shoot. Now the thing is, we already have a snapshot of these images. So in case anything goes wrong, I actually have snapshots created. Backup, not backup, actually snapshots. Snapshot of the NASA docs, 10,400 and something was it. Maybe the actually it was those were actually in mount folder. Don't you see anything? Like we had folders like test 24, NASA docs and extra. Don't you see anything? Don't worry, there is. I actually took a snapshot of the data drive before I mounted to this. So I think the snapshot should be somewhere in Azure. So yeah, just check it. If not, we'll try to do. There's a snapshot, I think. Thank God. I actually, for some reason, I don't know why, I just thought we should have a snapshot, and I just created snapshots in Azure and then kept it somewhere. I don't know where, yeah, the disk snapshot. So good thing I did it, because that took another 7 hours to download, because there was a 500 down 500 500 documents per 15 minutes, some sort of rate limit. Either way, I think it's out. We will check snapshots. Data disks. Yeah, snapshots. There we go. NTR is backup. We have it. This is the snapshot I took some time ago. if I mount this, will it affect the already mounted disk or something? Or will it be okay? I guess we already have a disk mounted. I'm not sure if mounting this again would, or doing this in a way might delete the, because all the Qdrant and stuff I guess is stored there. But if that's not an issue, then it's okay. Okay, so now give me the proper guide again. I'll follow it. Okay, so I just want to be just safe in case something goes wrong. I just don't want to afford anything because sometimes I do things in a hurry and just mess things up. So just take this slow. Create a disk from snapshot Azure portal. Go to snapshot. India backup. Okay, create disk from snapshot. Go to disk. Now I copied an image and tried to paste it here in Cloud Code. It didn't work, and I saw this tip. What should I do? No, I just want to paste it to you here. Okay, but I'm not able to attach. Uh, can you please check? This is what I see. Or should I click create disk somewhere else? Oh no, actually, Google snapshots. Create disk here. Okay, sorry. Google resource disk name required. TRS backup 2. Okay, review and create. Create. Yeah, because this is a snapshot and I had to create a disk with the snapshot. Okay. We'll select NTRS backup 2. Everything looks good. Is this fine? Can I create the disk now? Can I click OK? And I can just make sure. Looks fine. Same thing. Are you sure? Can you check it then? Okay, we have it. Good, then I don't think we need this. Okay. I totally forgot about it. Yeah, but before that, there's one small, I won't say issue, but essentially I'm using the API locally. So there's a different API that I'm using locally, and I'm only using this VM for Qdrant only, just to get the coordinate. So I have port forwarded the VM, which is only used to get the collections via localhost, and I'm not using the API for anything else from this particular VM, and all the API is there. Do you want to make changes here, or should you make, or how do you want to take this forward? Because the API itself is running on my Mac. Probably there should be some workaround. Maybe probably won't be much complicated. Just let me know. Okay, just changing the path, and there'll be one API that the other API would call. So this would just have one single API to just retrieve images and just give the base 64 of images, and then the rest would um the rest would just call the image and return it. That's it. Where your local Mac Next.js API backend VM this machine PDFs. Yeah, the problem PDFs on VM, but your API runs on Mac. Create a lightweight image service on VM that your Mac API can call here. 8080 Yeah. Yeah, and also use some random port because I'm sure I'm using 8080 or some other usual ports for other tasks. So just use some random port for now, just to avoid duplicate stuff. Yeah, so it'll be a fast API. You call it and you get it. So that's only for image services. Let's check Qdrant quickly. I think at least we'll be in that 600,000 range. Yeah. So essentially, we've reduced 300,000 chunks. Of course, merged it, but in terms of every single chunk, the computation of 300 chunks would actually be eliminated now. Okay, done. So you almost ran it for more than an hour, and right now we have 500,000. No, that's wrong. Actually, we'll check the points here. 600,000, yeah. Essentially around a 300,000 reduction in chunks. 300,000 chunks reduced, but we still have the content. It's essentially there. Just made it not as a naive 512 split, but a proper split. Chunk split. And just to test it quickly, I can test it. So I'll be like, why? Okay, make sure we use this collection going forward. Comment the old one and just keep this. I think there's another place you need to update it as well. I think we have a hard coded it somewhere. Just check it. Okay, production merge is connected. We'll try this. Now, when we should see huge, like we should see lengthier paragraphs than this. The hell? Okay, I think it got it. That's it. A single shot, it was able to pull in a lot of info. Maybe this is not actually showing the chunks. I have to check it, but let's see. We'll come back to this later. Check the images and come back. Sharing the image basics before. Let's see what all information we get. Basics before, metadata, and then the text and picture ID, document ID, everything. Oh, give me the command. So I will start the API in the VM. Well, it's already in use. I guess you should kill the port is already running, so kill it. I will run it on Tmax. So this API is running. Can you give me a quick curl that I can run on? Port forwarding is there. I also do want to run a quick curl to see if it's working on my Mac. Just run this unit test. Okay, it's working. It's working. Okay, now what okay, so we have to do over here. All right, now let's also slightly get back into something else. I've been now now you can see there is two calls, which is getting the visual region and getting viewing an image. I guess there's two tool calls that is related to images. Use both of this one. Now we're using the all the PDFs are actually stored in the VM. So it's actually no, that's not the case. I may be wrong. So would I need to change? Would I need to call this API when I call both of the tools? And you would return the base64, which the API will use it and return back to the UI, right? Just curious to know what changes in the Mac are needed. Can you quickly verify this view an image and verify all of this is true or not? Actually, you shouldn't have deleted them. You should have actually commented them, because in case we were to deploy this into a different VM, then we need to get access to this, right? So better if you just comment them, don't remove them. In case in the future we needed something to do with this, because all of this stuff is actually happening in the VM, but I also want this code source to yeah, code source to have that feature as well in case something moves on later. Good. Okay. Can you try it one more time now? I meant one more. Try it one more time. As part of this test, I also want you to view images, get visual region, use both of those tools. There seems to be some issues with your code, but these are the APIs. How do you want to make changes to the code? Don't code anything yet. Wait, but do you think the API you have created is very efficient? Because just check how we have the tools. Just go to agents and check the tools and how we originally do it. And I think there's some mismatch. There's some lag here. Help me understand it. Because the agent would make decisions if it wants to view a region or an image or a page and all of those. We have filters and etc. I'm not able to recall it properly. Can you recollect it in sort of clear? Just give me a clear understanding, because I think three endpoints. I mean, I don't know the reason why you even have three endpoints. Or just have two APIs, which basically mimics the exact JSON or whatever the input you get from the agent. Document ID, chunk order, and chunk orders. Visual region, document ID, page number, integer, optional. Okay, here are the new URLs. Please understand it properly and implement it. Okay. What is the issue? Do you want to curl manually and check if it's working in the first place? Maybe you're not using it properly. You need to check what response the API returns and then accordingly make changes to your code. So it will definitely return. It's just that it's not it doesn't know the JSON, right? So then it wouldn't know to extract them basically. Please try again. The images should render now. I meant, please try again. The images should render now. What images? This is a different document. This is fair enough, not a, because it's not a table you can't view. That's only, okay, images into the agent. Okay. Okay, so it's able to see that images into the agent. Great. Did you actually see the image or did you just read the description? Or did you visually see the image? Be honest here. Good. This is good. Cool. This works. Now I also want, you know what? Search for some images, rocket images or propulsion images, whatever in the collection, just be random, and then view the images and give me what do they tell about, like just the images and just give me info on it. Just to verify that it can see the not visual resume, a view image. So it comes across an image and then it can call it to check the images. So chunk type is picture, so we'll only end up with images. Okay, cool. Yeah, he's actually seeing the images now. Nice. Okay, you just saw it. Nice. Okay, so I'll be like, okay, just be honest here. Is this description based on the description you received, or did you actually see the image? Did you visually see the image? Okay, cool. So these were right. And some of the time the processing itself might be a bit noisy, so it's okay. So yes, it's working. Now what we want to do is that this is good. I'm able to say. Now what I want you to do is that I want you to in the UI um, maybe I'm not sure properly in terms of UX, where it'll probably be the right place to put it in. But I want to see uh, the images that the agent saw. So I want to be able to, in the UI, click on the images and just check all the images that the AI, the model, the agent was able to visually see. So how could we approach this? Like, if you want, you can use your front end skills, and I used your front end skills to build up the initial UI. So we need to make sure the UX and the UI is quite great, like how we currently have. We should go with the flow. So curious on it. Let me know. I think Perplexity had an images tab actually, but like Intraplex AI. So this is the platform that I'm working on. So shameless plug. So here you have images, and then you can see images, I think. Something like that. I want to be able to see images. That's the overall goal. Or shall we do something like this? It's fine. You can also show a small thumbnail preview in the inline tool result card. That is okay. But see the image. Once the final response is there, we can render all the images very small, like in a very small way. Before, yeah, exactly right after the response. So we'll show, like thumbnails of that, and the user can click on it and go through everything. What do you think? Please proceed with the changes. This is done, I think. On the snapshots, sources and UI. Hmm. Goodness. Just a minute, guys. All right, sorry guys for that. Maybe I'll do auto accept edits because it's UI, right? Not a big deal. Huh. Yeah. So hey, Thanker, just saw your message. Sorry if I missed it. I'm not sure if you're watching it. Yeah, it was a fictional project, but a fictional, strong, big project to be honest. So it's like a very much real world project that is quite fictional, but yeah, it's quite a big project. Yeah. Use Claude. Of course, I've previously worked on a lot of companies and a lot of enterprise stuff. So I thought this is something that is very complex that we need to show. And yeah, did some brainstorming and sort of ended up in this project. Yeah. Cool. We'll check for TypeScript. Nippon. Okay, so I think this will take a little bit more time. Okay, done. Refresh page. I'll go ahead and give it a shot. Just randomly search for liquid propulsion images, view images, and just give me random information about it. Let's see, embeddings are running. Right, it's viewing images. You can see all the API calls, everything is success. Right, was able to view the images. Hopefully, we should see a thumbnail of images. Nice. So see this and beautiful. This is very good. And this is the images, and these are proper images, right? You can see these are images. Uh, yeah, pretty good. So I'm able to finally see the list of image. Wow, this looks nice. Just see this, right? You see, the animation looks good. So upon clicking on it, I can see the list of images that the model was able to see. And yeah, this is pretty good. Yeah, cool. 4 images viewed, and I can see the images that was able to that was being viewed. Now I would also want you to do it for formulas, and I will also want you to verify the formulas by viewing it as an image. So sometimes some formulas are actually sampled out. There could be some noise in it. There could be some issues with that. So what we're trying to do is that we search for formulas, and then we results found for. Okay, we got a formula. Yeah, there was some issue with the searching stuff. Cool. So what we do is that the model can also visualize and see the formula, like take an image of a page or take an image of a formula just to verify that it doesn't miss anything. The formula itself, there's the different pipeline for formula extraction itself, and that's quite good. But just to verify that you can see formulas, just it's just there. So it's getting visual region, which is good, which is what we want. An image is sent, and we should be able to see it at the end. I think this should have been success as well. Image into 18, image into 18. Good. Alrighty. So the formalization would actually work. It's quite 95% very much accurate. But just to see whether we can actually view the images of those, I'm just trying to do it. It didn't show me the images yet. Just do it for 3 formulas. Once you find 3 formulas, just use the get visual region tool to get the image, and then just yeah, just show me the response. Just be random, maybe something related to rocket gas flow or something. So these are proper formulas. You can see those are formulas that you will actually get. And there's so many workarounds. Even if one fails, you can actually get the other documents and other formulas, get region, visual region, and etc. So there's a bunch of other tools that the agent can use is in case something fails, something goes wrong in document processing. All right, so let's see the image. This is one image, and this is a second image. right? So this is quite helpful where the user can actually verify this stuff, like verify the images. There's only two images that's been, yeah. So these are the two images. This is one, and this is two. And the model was able to pull this information, take a screenshot, and then actually see it as well. I would like you to take a screenshot of the entire page and read it. Now, these are stuff that I'm trying to like fakely sort of emulate because just to verify that stuff here is working. That's it. But usually the model would, if there was a need for it, the model would do it. Looks fine. Now I see a couple of issues. One is that when I ask a question and I get the images, that is fine. The first question under the I ask a question, then I get a response from the AI. I see the images, that's fine. But I have an issue when I ask a second follow-up question and then the text just lags for some reason, glitches for some reason, and then I get the final response, but I don't see the images. I'm sure it's with this image sort of thing. I don't see the images for the second follow-up. Like the fundamental trades of trade. Yeah, it's interesting because I've been doing something similar for the past month. Suddenly, everyone's sort of catching on to the same idea. Google has me a bit suspicious that they're promoting the same stuff I watch. It's using the same ideas. No, it's not really about the idea, bro. So, Tanker, I guess I can call you Tanker. It's not necessarily about the idea. I mean, you can build stuff, but getting in front of customers and really launching the stuff for product and then getting like being successful in that domain is very different. Building stuff, of course, like there's two parts. One, you build it properly and then you sell it and you do all of those business on the side. Both has to go in hand. Of course, building it is also very important because it's also like building it for a problem at scale. Like what do you want to solve? I don't want to get too much in like sort of business oriented sort of thing, but I'm trying to say is that definitely a lot of people might be working on very similar stuff, but your approach could change. Like yeah, you'll have something different to give, right? You'll have different ideas to give, or you'll have different concepts to give. You'll have a different perspective. Build with that. That's your entire. That's your use your intuition a lot, and then use your gut and use your natural design skill, natural approach towards the problem, natural product, and the product just has to come from you, and just try to be creative and try to build it on, and I think you'll be in a good spot. I think definitely. But yeah, tricky. It's quite tricky in the tech side. It's quite tricky, definitely. You don't. There's no one single way of doing it in the right way. You just have to figure out. So be random, pretty random enough to try a lot of things, and get into market as quickly as possible. Talk to a few people and etc. And then try to, yeah, build it on. That's what I can tell you. If Google has me a bit suspicious that they're promoting the same. No, man, I don't think so. Because wait, Google has a billion queries. They're not probably here to analyze yours or mine and get an idea from that. They have their own conviction. They have their own perspective of doing stuff. So don't worry about that. Just don't think too much. Build the product, get the first two, three customers, and then get the next 10, next 20, first 100, 120, 50. Just go slowly. I hope you'll figure it out. So good luck with that. Cool. We have sauces here. Very good. On the sauces, pretty decent ones. Okay. Cool. I mean, looks good. Uh, find me the recent NASA technical reports on rocket propulsion test failures or something. The reason 10 or 20. So this is like a data, like date time sort of a query. Cool. It messed up on the source because we don't extract this, but it's okay. Anything from 2025 or anything from 2020 to 25? The thing is, I want to quickly. So the thing is, I'm not sure. I want to check the carbon collection to see if there's any way, or not a way, but do we really store? It's very old documents. Very old, 2011, and etc. I guess these are very old documents, very much old. So it's Okay, thanks. Now, could you quickly check Quadrant? I guess I was doing some metadata extraction for all documents. I guess we were trying to extract the date in which the document was created or something like that. I would like to know whether this quadrant had does quadrant have those information? Because when the yeah, just curious to know. It's fine. I'm already running npm run deb. Okay, okay. Okay, we will do the retrieval part at the end. So we'll spend some time on it. What the hell are you even trying to do? I simply mentioned you check the document processing code, and we were trying to extract the date, the report date, or the year of the document that, or year the document was created. And I would like to know whether we are saving that in Quadrant. Simple, idiot. And yeah, the whisper flow just removed the idiot part. Yeah, so I just want to check if we have documents, because some of the documents might not have the created date, like it wouldn't probably have that. So Oh shit. Oh my god. Shit, I didn't save the report date, I think. Oh shit, such a bummer. Actually, I think I processed it. I added the feature, but then the VM had the old code. And when I started the process, I probably didn't have the report here and etc. I forgot to add it. Shit, that's a bummer. Such a bummer. But what it can do is that now check the document processing, so not the document processing, the agent tools and etc. And for some reason, the report here was actually not processed. Probably I ran the code, the document processing much earlier than we implemented this, but I'm not sure. So Obama is there right now. We don't have a way to check the year of the document. Like we can't we're not able to check the year of each document. So we could have, but the processing failed. So a workaround for us right now is to do keyword search, exact keyword search from 1920, 21. So there should be, because we don't need to do semantic search for this. We have to do keyword search for this, and we can probably um, land at something. Something has to happen. In this way, we need to have some tool uh, to do search based on a given year. Like let's say we need documents from 1980s, then we should be able to just do 1980s 19, like put in the year and then just do search in that space. Like we don't still have the metadata, but we can do some sort of keyword search or something like that. That should be some approach. So think about it and let me know. We can figure this out. So it's so important. I messed it up. Definitely I messed it up. I accept that, but yeah, there should be some workaround to it. So let's see. If not, it's been super easy. We have we have information, like information on it's this document is from 1981, this document is from 1982, and etc. We usually have it in Qdrant. um yeah, it's a bummer, but it's okay. Can you just verify metadata just one more time? Don't we have, just check. I think yeah, I did check, but it's not there. Oh, you know what? Yeah, I think It's all on me. Cool. Looking at the document, I notice a pattern. Yeah, you can do it through documentize itself. Yeah. Yeah, this is good. Yeah, now I can do something with this. Damn. This NTRS numbering system. Good, we are dealing with an NTRS numbering system. We have a workaround. If not, we have to reprocess that. But you can reprocess the documents. I mean, not a big deal. Just spend another 2 days. That's it. No, check the existing code. We already had a way to save report year and etc. I think, which was actually failed, which the during processing it failed. But yeah, we can actually extract, look into the documents IDs and then update that field in all in the Qdrant metadata. I think just check how we do in the document processing. We sent two images, the first two images to Qdrant to pull in the year of the document. So probably what we can do is that get this here and then just use the same exact fields and etc, but just update it. Just check the code and let me know. So it'll essentially be like it's a savior for us because they have a very good numbering system. We're in good hands. We basically have to just process the documents because all the documents you can see over here do have the year, or at least like this stuff I've renamed it to be table man just to see because it's had a lot of tables you can see over here, but usually there is a number over there. Okay, so what we just do is that update Qdrant to get the first year and then we update document metadata to do it by year. Sure, but before a question I would like to just know whether we plan to whether the initial report here was actually stored for every chunk, or was it only uh, or was it only part of a single chunk? So, I mean, like metadata of a main document, like an abstract or something. Did you check that? Yeah, this makes sense because in this case, if that's the case, we literally can pass in the year or a range of an year and just get the chunks that is actually from that year. Cool, cool, cool. This is a backfill script. I should, you know what? Actually, all of the documents are actually in the VM. So just give me some information about what needs to be done, and I will pass it to the other Claude agent in the VM, and it'll basically get it done. Because no point adding it here because all the documents are in the VM. You might also want to look out for edge cases where sometimes there could be text in a document, and then you could have sometimes there could be text in a document, and then you could have the year. If that's the case, it's fine. You don't need to do any rejects with that. Just keep the year as empty for those documents. Actually, the thing is like this, guys. We don't need to even think about that because all of the documents we have are actually clean, and all of them uh, usually are usually usually is quite clean. So if I come back, I don't think I've never seen any document that has a lot of text initially. They could have limited this 24, and you can see, yeah. So this is another, this was one condition. So this is okay, 2009, but this is from 2020, I think. Yeah, so then I think this is one scenario. So what we can do is that just copy this. For example, I saw this. Maybe you can work out this for this edge case too. But don't worry, usually all the documents, like 90% of the documents are like in that proper format, so it's okay. And maybe as a fallback, you can write something for this format. And if not, if it doesn't still work, we just we just don't have any, and that's it. Give me your thoughts. Actually, ear, not ear. Shit, it's fine. To pronounce ear right.
Yeah,
Yeah,
yeah.
yeah. We do this. Yeah, yeah. So it's yeah. Okay, strategy one, most likely. Strategy two, and second one, most aggressive, looks for an ear, doesn't fail, falls back. Background. Okay, so so 99.9 exactly 99.8% will be updated. It's very clean. Only 2% could be extracted. That's fine. We'll leave without any. That jam not 2%, 0.2%. So not an issue at all. Let's give me the command and I'll run it. You know what? Just run it. No, because like this would actually affect context. So I'll run this. Okay, I think it's the processing is going on, but I hope we can actually start working on it. So the whole idea is that no, not the idea. So it's currently processing. So we'll actually work on it. Before we make any changes, now this is very important. The system prompt, the tools, and the document processing, the metadata, everything works in a flow in a pretty much very good hand-to-hand approach. So everything goes in a flow. That is, we've made sure we haven't duplicated anything. We've never confused the model with anything, and etc. So I don't literally want to confuse the model at all. Check the system prompt, check the tools and etc., and come back to me saying where could we add this ear filter, where this could be, where would it make sense essentially, or is there any other options or and etc. So just give me some info and we'll come to a conclusion on it. But yeah, it's important that you understand that everything is on a flow and it's essentially like a brain. Like you can't just add information, add just filters and etc. We have to do something that makes sense. So yeah, do the research and come back. Oops. No, come. Wait for what? Wait for what? The collection are you literally running this? We have to run for production merge collection. This 900,000 chunks is this collection, not this. Okay. It's fine. We're already running it, but just curious, in case in Qdrant, if I wanted to search it, could I search for range, for example, from 1950s to 1960s, documents that contain schematics or failure modes from 1950s to 1980s? Could I do a range sort of search? Will it use the full capabilities of Qdrant, and will it numerically will it work? Because I don't want to end up in a situation where it needs to do sort of like basic matching and it's super slow and those shit. So I don't want that issue. I tried running it and I got this error multiple times, but I didn't quit. I didn't do anything. Please increase the timeout. Please increase the timeout. At least we would need 20 minutes for this. No, it wouldn't take 20 minutes. Just putting there less than 10 minutes. Right? It's much faster. Okay, so let's see this. Now I have complete understanding of system. Again, same thing. This is probably some issue with the timeout. Can't you increase timeout? Like it was only running for like a minute or so. We'll try it again. Okay, this will run. We'll wait. Yeah, the existing filter mechanism handles simple key value matches. For your ranges, you need to extend the support. Oh yeah, but just curious. Let's say if I wanted to find documents from 1950s, then essentially you can't. We need to support a range, right? We have to support both. We have to find if the user was to find from 1952, 53. I mean, it was specific. Then we do, find it specifically, or maybe even the range would also be very much helpful. The range would definitely be helpful. So I'm curious to know how would we handle range? Does the current processing um, allow for that? I mean, it's not a processing issue; it's actually a searching sort of issue. So curious to know, will this make the search slow or etc.? Or is it the native Qdrant search? Or I just want to understand the technical part of it in terms of efficiency. What happens under the hood in Qdrant? Because if it's a essential text match, then it's essentially text matching to all the chunks, and not sure how efficient is that, or should that be indexed and all of those stuff, and how would range work for this? So keep your stuff concise, your response concise, but give me a proper understanding. A short answer: range filtering order is fast in index, not a slow scan. Cordon uses payload indexes filtering. When you have a numeric field like here, index by default, Cordon automatically creates an index for payload filters. Filter happens fast, Cordon narrows down candidates using index before doing similarity, not a full scan using B3 like structure numeric changes. The commerciality, yes, we do it. See? Okay. Okay, does this so basically would this mean that I need to make any changes to the processing, or we are good to go? Because the documents are currently being processed. Because, because currently the quadrant is being updated. Yeah, let's make these changes. And here you can see here is 1964. This should be 1993 and etc. This is 2014. In 2014, yeah, right. Here it looks good. Because it's very important, at least at this use case that we are building for. People might just wanna, they'll just have an understanding. Okay, we worked on it like 7 years ago, and 7 years in terms of if for like rocket propulsion stuff, it's like it's very it's not a huge number, to be honest. That's why they work with documents or research papers that span anywhere from span for the last 50 years sort of thing. So usually that's the case, and 5 years, 10 years, 8 years of research papers are still sort of relevant. Not 100% relevant, but that's one of the research they do inside the company. So it's usually somewhat relevant, and they would want to see where stuff failed, and etc. And they work on a very long-term pace. So this, I mean, it's just adding a very simple support of being able to filter all chunks by ear itself is like a big unlock for them. Like they can literally go ahead and search, because usually companies, they can't search. Like how do you search? You can use it with metadata if PDFs do have like good terming like conditions and etc. Traditional search, but usually not the case. But this you could, like, each chunk has information about what year the particular document or the ID from, and then we can filter it based on that. So it's definitely unlock. So once this process is done, we can actually fire the query. Um, yeah, we can actually quickly check this. KPI is now on. Sure. Hmm. Find me um find me cryogenic system. Find me cryogenic engine systems from, or test failure systems on related to them from the 1970s to 1985. So anything that is in bit, I won't do that. Let's see what the search will have, how the search will go through. Better if you can find me something from 1970s. We'll just do 1970s. We'll see what it does. And start the year 1970, 1970 and then 1979. Let's see. This, I can verify this easily. So you can see this 1970 number. Everything is from 1975, 19. I can see nothing is above 1970 or 1980s. So everything is under 1970. I can confirm that because you can see the IDs over here. Good. But so yeah, it just got it. That's it. Simple. Or it would have been quite hard for the agent to work on stuff like this. So this was quite good, I would say. It's filtering through pages, firing more. Okay, good. All of this are related to 1970 documents. Nothing in the 2000s. Nothing in that set. And it was also able to view an image. So let's see what it viewed at the end. Okay, so we'll look at the image, and this is the image. I know image is not that great, definitely. Caption: variation of end-user calculation performance with flow coefficients is from 1977. So exactly the copies and the images could definitely be quite of an issue, but you can see it was able to accurately pull in the image and also view the image as well. which is what more than that's more than enough. And you can see the chunk, you can see the sources over here. We've got very good amount of sources, and if you click on sources over here, you can see all the sources that the model actually went through. So you know that the stuff here is actually accurate, and I think it's pretty good. It was able to do a very good job based on date based filtering. Such a good job. And sample document IDs without extractable years. What I would do here is that we can actually filter them as well. We can add these documents as well. Actually, no, guys, we can't add it because you can see this has no meaning. This particular document has no meaning. This, of course, you can see 1924, and this exactly has no meaning. We skip that. But at least let's send this to Claude and be like, maybe we can uh, maybe we can do it for this pattern. Seems quite simple, so maybe we can process documents with this pattern there as well, right? It's quite simple. This pattern is quite simple. You have a space and then 2024. This document is from 2024. Just get 2024 right after the space. Just add the button, add that button, and we can reprocess it. So will it process the other documents as well? No, right? Just the ones. Yeah, I guess so. Because you can see the speed is like quite slow, so quite fast. Probably do it for the documents that is document that is already not processed. Yeah. Then I'll be like here. Thank you for the info. I also want to. I would like to. Mm, I would like to check for the same info, but then for the recent documents, probably in the probably any documents or anything that we did from 2020 to till now, to till date. Okay, let's try this. You can see the notes and the tasks as well. So this is agent's notes and this is agent's task. You can see all of these documents are from 2024. So all of this you can see over here. 2020, 2024, 2024. Start year is 2020. Everything is from 2024. So it has 2020, 2024, 2025. So yeah, very good information. And you can see because we're filtering it, boiling down into a very reducing the embedding space, the time to token or the time to quadrant hit to come back, which all of the chunks is also slightly fast, not a lot fast. I can feel it. And searching this and within a year start 2020. So it's basically it's just reducing all the noise. Whatever is from 1970s doesn't matter at all for it now. It's just working on time specific, time boxed information. So yeah, got good information, I think. I also want to work on references. So Oops, this is for now. This was that. Some documents might reference some other documents, so the agent should be able to look into references as well. This is very important in this domain, where one document would have basic information, but the references could lead to something important. So yeah, so this can be added as a tip to the agent system prompt. Not no heavy work required here. Ear, or should I can pronounce it? So this actually looks good, I think. So major reason, NESC propulsion transfer review, a review of space propulsion transfer capabilities from NASA system, OSA mission 2016 to 2022, 20, and then 2018. So it was able to pull this as well. So I'll be like, what's the main differences in terms of technology from 90s, 70s, whatever you was exposed to, and in the 2020? Just give me key major three differences, the same systems. So, based on what I found in the archives, here are three major technology differences in the cryogenic propellant space from 1970s to 2020s. System relied on passive thermal insulation, KELF coatings applied to pump inducers and inlet ducts, whatever the scientific stuff this is. And here you have 2020's RRM3 demonstrated 4 months of zero boil off storage during active cryo-coolers, maintaining methane at 9200 K in space. A completely different paradigm. Long duration now demand active refrigerator cycles that rather than passive insulation. So this is the source. So I think it's pretty good, at least very much useful for the people who for, this system to be in the right hands. So bottom line, the same basic system, but they went from hours of operation with human watching in 1970s to months of autonomous operation with robots in 2030, enabled by active thermal management and integrated. Okay, this looks good. How many? So I just want to know what was the timeline like. They started from 1970s. Just pick one thing. They started from 1970s. How many research it took, and what were the timelines, and how did they end up in this? So I would like to know what research went through on which timelines, and then in terms of timeline, I want to give you timelines or information. What research, what failures, what tests and sorry, tests and etc went through, and how did we end up at this paradigm right now, new paradigm right now, the 2020s. So just give me the entire timeline. So I would like to see how it could work through this. Let's see, because what essentially one trying to say is in 1970s the system was like this. I sort of get what the system is trying to do, and then you have 2020 where everything's automated. You have different types of cooling, better cooling, and etc, which is autonomous. But I want to know what was the timeline. Like, they did a ton of research. Is the research documented? What were the trade-offs? What were the tests? What were the collaborations made? What is that technical breakthrough that made because see, it's 1970s to 2020s, actually 50 years. So they've definitely done a lot of research, failed in a lot, test has been successful. Some of the tests have been, the failures, learning from the research would have been very much useful for the for the next test and etc. So I'm just trying to understand the timeline. I'm not sure how we'll search it. So I think it's starting from 1970s. Now the thing is like this. I don't think the agent has access to all the all. So let's say I do a second follow-up question, right? The agent only would have the final the response, the final response it provided. So not the other actions it took to provide the final response. Um, just saving up context at this stage. It's okay because the final response will have a lot of sources, right? It can still look into the sources and pull in the right docs and search it. Not a big deal. Plus, yeah, and it's just a matter of adding something like max mode to enable that context. And this is Haiku, by the way. Haiku itself is like doing a very good job. Can't imagine if you do it with Sonot, or if you just add Opus, the sort of the work that you can do and the deep search, the research trends it can launch. This system is quite powerful. It can compete with, like, easily compete with companies that have millions of dollars in funding. yeah, easily can compete with systems like that, and even outperform them as well in many ways. Okay, we've got the 50-year evolution. I'm not sure how it went through, but let's see. Seems like it's giving you the answer. So this is like timeline specific information. It's quite huge for people, like people who do research. At least in my side, if I can get access to like time specific, time box information, and research involves through time. So just adding, it's not just date type filtering; it's the entire thing. It's just everything is working hand to hand. Yeah, let's go. I would like to see the mm, system searches. It's from 1920s, 2020s, and it has also searched stuff from I guess 2000, yeah, so 19, so it was 1970s, and then it was 1980 to 1995, and then again from 2010 to 2020, and again, yeah, and then yeah, it pulled in some information. Looks good. 50-year evolution. Starting point 97, ground-based limitations to constituting space propellant supply have existed theoretically since NASA's earliest days, but never operationally demonstrated. The 1950s saw Moore and Ming at Lewis Research Frontier. Damn, I think this is good stuff. I think at least if any research folks from NASA or something, in later in some time, if you were to watch it, reach out. At Intraplex, we actually solved not Intraplex, but this is what I'm trying to solve with any system that I do. So happy to build systems, custom systems, or maybe deploy already developed systems for you, because I already do have a lot of systems that I can deploy. So I think definitely will be helpful for you guys if anyone were to watch this. So the space tug war to MVR, okay, recognizing the knowledge gap. First space experiments 1984 to 1993. Orbital refueling system ORS achievement 904 lbm. N2H4 transferred 6 tank to tank transfers 285 minutes overflow. Proved ullage compression more isothermal than adiabatic. Damn, I don't know how to even pronounce this. Relieve the overheating concerns, blah blah blah, and all of this stuff. And then phase 5, they had in the 2011 to 2019, they had ISS based robotic testing, and then they had parallel ground cryogenic propulsion system storage and transfer. Phase 6, modern autonomous service, and this is where 2016 to 2023 we had non-cooperative space from advanced interfaces. Here, precision systems, helium leaks, robotic mating to non-cooperative client interface, blah blah blah. So much. Parallel geoservice development, pump designs, major to proof of concept. Wow, looks good. And then this is the entire timeline. I think this is very good information. I'm not sure how true this is, but I think everything is based on sources. So I think some level is quite true. And I think in terms of starting point, this is more than enough. So yeah. Turbo era station concept, quiet development, autonomous proof, and then infrastructure era was 2020. So it has taken so long. What I'll do is that one image viewed, and you can see the image viewed. So if I were to click on this, sometimes the document processing might have issues in tables, and it might give you wrong information. So I guess the model probably reviewed this, just took the screenshot of the image to even understand this much better. Okay, and this document is from 2020s, which is also good. So now I can verify what image it did view and etc. Okay, cool. I think this is good work, good job. I think in this side, very much accurate. I'm going to print this conversation in case I want to come back. Yeah, in case I want to come back in later point in time. So I'll do Control A copy because I don't think I have. And I'll save it in a docs or something. Just put it here, just randomly dump information here, and then I know because and there's like 59 pages, sort of like, no, I don't think so. Okay, not 59 pages with sources. I'll create, just put full conversation with timeline cryogenic engines. Cryogenic, not cryogenic, cryogenic. This was the first question. And we've never entered, we didn't still enter deep research mode in the first place. This is just the normal agent that didn't even launch any research thread, did the work by itself and etc. But if we add deep research support with research thread and opus to it, this is 1,000 times much more powerful. I'm not sure what the possibilities are endless for a system like this. And this is haiku with no deep mode, kept on context and etc. Yeah, I think system is doing quite well. So cool, we'll keep it as it is. I think there's still some work to do. Overall, happy with it. It is able to pull a lot of stuff. Yeah. So based on air filtering, very good, working fine. What else do we have? Backup snapshots, that is already there. I'll actually make a snapshot one more time. So this would be snapshot of this, where is it, production merge. Go to snapshots, take a snapshot. So it'll take some time. So same thing I did with the old one. For some reason I got lucky. I just saw snapshots and I was like, what does it do? I just clicked, and I mean, of course I know what this do. It was like, should I just click it? And I just clicked it randomly, and then it was quite helpful. So you would never know. Yeah, just gonna take a snapshot. Okay, so there is a snapshot over here, 3.7 GB snapshot. Copy this in case some things go wrong or something happens. We always have something to fall back. Okay. Okay, so backups, image not being visible. I think in terms of system, I think this is doing a good job. Um, so we'll actually reconnect to this. We'll quit this. If I'm gonna quickly pause this. Okay. Cool. I think finally we have our final test to go. The final test would be validating that this works in a space of 10,000 documents, how accurate is it, being able to work on it, and etc. For that, I need to prepare testing data. And then I want to, so the whole idea is very simple, to be honest. I'm going to give Gemini access to 25 documents and then let it ask entire full 25 documents and let it create me question pairs. And then I would go ahead and ask it to our system. Now the our system would not never know, and probably have to the current Meridian system would need to, or our agentic system would need to find that 25 among that 10,000 documents. And this is where it will work. We will see how it's working and whether it's working the right way or not. Because that's essentially it, guys. At the end of the day, the agent needs to read a few hundred, it need like maximum 50 documents at a given time or a given query. And then the whole goal is that finding the right 50 documents among that 10,000 documents or 7,000 documents. Simple, nothing much. It doesn't read all the 10,000 documents. That's not the case. It just need to find the right 50 documents among the 10,000 documents. That's what we're trying to validate. We've already solved it. I just have to validate it and sort of just do some final touch, and it should be ready to go, I think. Yeah. um Okay, okay, dokie. Hmm. Okay, there's the VM is already running an image service. So it's called health. Okay, it's already there. I think the image service is actually running the old collection. I want you to use production merge collection, because you can see it's running production final. That's the collection ID. So we just want to update it. Oh, this is why the descriptions were failing before, because the order ID were different. Orders were different in both, because we merged a lot of stuff, so orders would have been very much different. We don't want to kill it. We'll just run it one more time, and we'll check the health. Okay, it's using production merge. Good, 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 good stuff. It's I want big text saying quick lunch break. It's good, right? Just generated it. I'll come back in a few minutes. And next we are going to be working on evaluation. So essentially what we're trying to do is that, as it is mentioned, we are trying to find that 20 to 30 or 40 or 50, whatever the document it is, among the 10,000 documents. It can even work with 100,000 documents depending on the infra you have. And yeah, get it sorted out, evaluate it, and you're done. We're good to go. And I guess the system is up and running. We've pretty much, if I see this, pretty much done all the stuff that is connected towards it. I think what else? Yeah, that's it, guys. We'll come back in a bit and quickly wrap things off. Just run on, just quickly, yeah, just work on a bunch of stuff once I come back. Okay. All right. See you in a. You know what I'll do? Expand this so you guys know what is going on. I'll come back in a bit. Okay. Right. Let's do one simple check. One more time. Yeah, so filtering is working. I just want to verify it. I made some changes to the. Yeah, just want to verify. All right, cool. So yeah, let's jump in. Let's jump into the most important final part here. Um, and yeah, it's called generated files. Okay, make sure to quickly check the code. We basically went through the entire quadrant and we came up with 20 to 25 files that I could use, send it to Gemini, and create question pairs and etc. I'm not sure where the files are and etc. I want you to check on that. But the thing is that uh, documents were quite huge, and I was only able to put in like 10 documents because it was quite huge. What I want to do is that I want to get into Quadrant, check the initial code obviously, but I want to get into Quadrant and keep the entire context under million tokens, and at the same time have about 25 documents at kept at about million tokens, or maybe even 30 documents, maybe even 30 documents, whatever, doesn't matter. It has to be less than million tokens, and then it has to be less than million tokens. It has to be around 25 to 30 documents. So I want you to check the previous doc and come up with an approach whether how we can get these sources, because essentially what I'm trying to test is that Gemini would or whatever the model, high context model, would have access to all of the docs. They can ask questions, which means that they can create questions that can create a lot of cross references and etc. And our agent in the head should be able to find that 30 or 40 documents, cross references, given output in a space of 10,000 documents, so that finding that specific docs or that needle in a haystack sort of scenario. So yeah, I want you to spend time on it and get back to me. Doing code. So let it do the work. Image service, this is also ready. I think everything here is ready. System itself is doing well. And yeah. Okay, some documents may reference other documents, so the agent should be able to look references as well. Yeah, true. This I have to check. I've not tested it. I think it'll do some work. Mostly it might work, but let's see. Actually, it was here. It was generated documents, eval. Yeah, eval documents. There we go. Here. I'll be like, the files are itself quite huge. You can check. There's a folder called simulations, and there's a folder inside of it called eval documents. Don't try to read the entire file. They are quite huge. Yeah, got it. All documents are MD. 3. Suggest that you've already trimming to 12 docs. The problem 25 docs in average finals. 7.5 million tokens. So you get 1 million token here. You need 30K per document range. No. That won't be right. So what I'll do is that maybe we'll try 15 docs, but no, that can't be true as well. So option is select smaller documents, check Qdrant for documents which chunk count. Let's try with smaller set of documents now, and then let's see what we can do. Um, properly create a folder and put in the MD file properly there, because we will probably be, no, I will be like, let's try option 1, write the query, properly create the folder, because we'll probably be creating multiple data sets or multiple versions of documents like this. So yeah, and enter. Mhm. The target 30 documents stays under the string, estimated 30 docs, 100 chunks, 900K tokens. Yeah, it's a good number. And I also, in some way, wanna, what do you call, create, oops, interconnected documents. I want to find relevant documents, not everything. Small docs, future photographers. So, come. We'll be back in a bit, guys. Just a minute. ஒன்றரை லட்சம் இப்போ இந்த வார காலத்துக்குள்ள 1,50,000 கொடுத்தது, மற்ற 1,50,000 வந்து அடுத்த மாசம் கொடுத்துருக்கு. ஓகே தம்பி, அம்மா சொன்னேன் காரை வேணாம் இப்போ நாம வைக்க வேணாம்னு சொல்றாங்க. கூட்டே வித்தாலும் எனக்கு தெரியும் சரி, காசு இருக்கு வேணா நான் அதை எடுத்து வேணா இன்னொரு கணக்கு வேணா பிரச்சனை இல்லை. எனக்கு தெரியும் இப்போ நான் 2 வருஷம் செஞ்சுட்டு ஒரு 5 வருஷம் வாழ்ந்துட்டு தராங்க. 5 வருஷம் இல்லை, அது ஒன்று கொடுத்தாங்க 1 வருஷம். சரி 2 வருஷம் சரி வேலை செய்யும் வேணா வாங்குவோம். இது வேணா கொடுத்துட்டு அன்றைக்கி நான் பார்த்துட்டு இருந்தேன் எம்ஜி கார் இருக்குது, அது 98 lakhs இருக்குது. இப்போ 65 கொடுத்தா 30 lakhs போட்டு 10,000 கொடுத்து அதை வாங்குவோம். இதே பால் இதே இது ஒரு $1,000 கூட இல்லை. இதே பால் Sorry guys, had to go out a little bit. Copy this to the selected JSON and filling the documentation. Guys, I think we should try to do topic-based testing, uh, because very different topics will have very different amount of testing required for it. In terms of, I'm saying technically, I don't know the technical concepts, but I think we should have some sort of technical sort of logic slash technical slash related concept testing, because some documents will be in 1970, some will be in very different documents. In a space of 10,000, you can find certain documents, for example, like the timeline documents. This you can't do it you can't do it properly. So then we have to just use keyword search and try to find documents that are relevant to propulsion system, relevant to failures or whatever. And then what we try to do is that then we actually go back and um, try to create a 12 document dataset that's actually correlates to each other, one another, sort of thing. But this is fine for now. We just have to do a very small test. It's okay for now. And this is taking too much time. I would say we don't need to spend time like this, to be honest. We can just randomly select documents, for example, in a range, documents from, I don't know, just look at documents from 1970s to 1990s, just and just randomly select 10 to 25 documents with 10 to 25 documents. I don't think, because this will definitely take a lot of time, which I don't have. Because if we do it for 150,000 chunks, that's 600,000 chunks. And then again another, so not another good option. Randomly pick stuff, just create some random stuff. As long as it's under 1 million token, we're good. So randomly grab 25 documents, you're 90 to 90. Yeah, that's what we want to test. The second test, we'll do relevant test, and third, we'll see what we can do. This will take a couple of minutes, and we should be good. What else is on the plate? I think need to have a way to add documents related to a project. No, that's like essentially like Cloud code, or no, sorry, Cloud, where you can have an interface to drop in relevant document projects you're working on. For this system, currently, it's just a good to have sort of thing. So we don't need to spend time. Later, maybe if I were to continue the series, I will build it. But we are already 1 week late. It communicates the knowledge base assistant based on a perspective. For this, fine, but we need to do the search system. We're trying to do this in a while. Metadata document processing. Vertex inside system, domain terminologies, chunk issue, image not being visible. Some documents different, some other documents, so the agent should be able to reference. Yeah, that's the only last part that is left. Estimated tokens, total chunks 410, estimated. Okay. Okay, now I think we have to run export document. .py. Average 16 chunks each. Very, very small document. Very small documents. So we'll see combined. Okay. 122,000 chunks. Still a good number. But sometimes the conversation itself will be 120,000. So it's 120,000 chunks, it's not a big deal. We'll do increase to 500 and get more to get more docs. Hmm. 40, yeah. We'll try this. Quick select. Still estimated token 192,000 chunks. Where is that? Because chunks are, I guess chunks are big enough. Even 33 chunks, those the specific chunks can be big enough. At least I need 500,000. So what I'll do, we'll actually go from 1960 to 1990s. Because the older documents are much more, they have a lot of chunks. You can see 1970s have 1520, and then the recent documents have a little bit less. So hoping 1960 to 1990s might bring in some extra documents. Run it. I'll do some quick brainstorming. I'm just putting information about what we're building. And there was a conversation called Sandra. If you were to look into our old like day 3, day 4, we made a lot of simulations to be able to figure out how a system should respond. So created personalities and etc. So yeah, so I'm saying, just go ahead and refer to that simulation. And this is what we are building. Okay, so 240,000, 240,000 estimated tokens. I think I at least need 400 to 500,000. Not sure what is the issue. Estimated tokens. It's fine. We'll go ahead and export documents. It'll definitely be more than what it was. 2,000, 15,000. Review for. Yeah, so I mean, we've long way from here. The system is already working quite well. And right now I am in the evaluation phase. So trying to evaluate the system, the system probably has about access to around 10,000 documents. And I'm trying to evaluate it properly. And I'm actually trying to evaluate it like, I mean, like actually, like literally, like in a way that really makes sense. Of course, there's no any benchmarks you can run. You necessarily the most important feature here is accuracy, being able to find the right document. So my idea or thesis is that even though you have 10,000 documents in a given space, the agent literally needs to find the right 30 to 40 or maximum 50 documents to be able to answer that question or do a deep research or provide a solution to the query to the user. So if that's the case, what I'm trying to do is that I'm creating a data set of 25 to 30 documents. All the documents will be given loaded to Gemini or high context model or models like GPT or Gemini or a model that can load the entire 25 documents, which is around 300, 400,000 tokens entirely. And I will try to create a question and answer spread, like complex ones, things, because the Gemini is privileged to do it because it can refer to all of the 400,000 tokens, which is entire 30 documents, and come up with the answer. And what I want to do is that I want to test that exact query to the agent as well. Now the challenge for the agent is that it should find the right 30 documents that Gemini is referring to, which in that 10,000 document space. So that is what I am trying to solve. So that is one good, or most of what a good evaluation framework might cover, and I think that should do the job. So I would like to know your thoughts on that. Apart from that, I also would like to know what is any like how like what are the few testing evaluations that I can run through, like similar to this. What are the other stuff that could make sense that sort of helps me or evaluates the model on certain criteria, being able to understand this, because aerospace domain itself is very different and we are building it for a very niche domain, and I'm pretty sure that the answers or the system should work in a very different way for the specific people. So I would like to test it in a few aspects of it. So I would like to know what aspects could we test on. This is one, and similar to this we can actually test a few different aspects to it and then evaluate and tell, okay, we've tested this, we've tested that, we've tested that, a very different scenarios, we've tested this personality, we tested this skill accuracy and etc. And then 3 or 4 to 5 of them, and then try to give a score to the entire agent, which a way that should actually make sense. This should make sense entirely. So I think I just talked a lot. So so yeah, deeply think on this and let me know your thoughts. Because that's one set test scenario that I want to work on. There could be a couple of other test scenarios that I want to evaluate as well. So I'm thinking, what can the evaluation be? How could it be? Core ideas sound and actually clever. You're essentially creating goals and being high context model. Very good accuracy testing. One, retrieval accuracy, cross-reference navigation, degraded document robustness, domain reasoning, and negative boundary queries. You ended up with 50 to 50 test cases, 5 dimension. Each dimension gives its own score, and you can create weighted composite score for our system. The weights are suggested, retrieval accuracy robustness has priority if the system can find the doc, or if it hallucinates, nothing else matters. Domain reasoning is next. It must interpret correctly. And one more thought on your Oracle Medal. When you create 25 to 30 document evaluation, you create them. No, that's the thing. Same program, same era. We can do it with timelines, but quite tricky. Documents that span different programs but share a technical theme test the agent's ability to connect across contexts. Documents with heavy cross references between test graphs navigation, mix of clean degraded reward no. Looks good, but yeah. So, actually, you know what? This is actually good. We have to test with all scenarios. Done. So estimated tokens 700,000. Good, very good. I'll click on it. It'll actually crash my PC. I think if I click on if I crash sorry VS Code PC. Okay, this one. It's a huge dock, quite a huge one. It's very huge. So what I'll do is that we'll do open reveal in Finder. Go to Gemini. Let's create a new conversation. Drop in this MD file. This has about 700 and yeah, around 700,000, 0.7 million tokens under 1 million limit. Yes, around 40 documents. Okay, it's a good combination. Like this is good. Now, could you help? Now, I'll be giving access to around 40 documents to Gemini. I would like you to create a prompt that I can send Gemini, which would probably um, give me. Now, I want to do everything in Gemini itself, so I don't want to complicate this, but yeah, give me a prompt that I can send to Gemini, and that would put test of all of the above. Now, what I would do is let me think about it. This is for Gemini, and I want Gemini to create me. I mean, at least for now, I want it to create 5 scenarios or 5 questions, which would actually test all of the 5 or combination of 5 or combination of a few or something, because we don't need to have each query that would test retrieval accuracy and another query for cross-reference navigation. Essentially, one single query can test multiple aspects of it. Like you can literally do it. So what we want to do is that right now is to have help me generate a prompt that would generate me about 5 use cases for now that would start from a medium spot, and then at the end we would, or whatever, a combination of whatever, but at the end we should be able to get we should be able to um, we should be able to uh, uh, tick all the scoreboard stuff. So I want the agent to test all of the stuff that we are trying to test on, so all of the 5. So what is your approach? Do not create the prompt yet, but I'm just curious to know. Right, so essentially what we're trying to do is that I want to test the agent on all of these boundaries, which will accuracy, cross-referencing, degraded documents, domain reasoning, and negative prompt queries. And yeah, so yeah, phase one before generating question, Gemini needs to build a roadmap of what's working. It should produce a structure catalog of what documents covering. Yes, this makes sense. There's also one more point I want to add. For example, let's say Gemini were to create a question, right? Gemini only has access to 40 documents. Now, our agent, like our agent has access to nearly around 10,000 documents. Now, it can come across a different document, and that document could still be correct. Like it could, for that specific question, it's sort of like a problem with Gemini, because Gemini only has access to 40 documents, and the agent can actually have access to 10,000 documents. And for that particular question, the answer could be correct in a different document. That could happen, because we are not dealing with math here. We're working with information, research, and etc. What some research could just change the trajectory of the answer, and it can still be right. The only miss is that Gemini is not aware of it. How do you think we should deal with this? Okay, so it's giving a catalog. So we have a catalog of essentially what we're trying to do is that we have a catalog of we have we literally have a catalog of all the documents sorted out. So what is the key concept? What are we talking about? The quality, the cross reference. Does any other document reference any other documents? Like is it any correlated to test everything? And our goal is to test retrieval accuracy, cross reference, degraded documents, domain reasoning, and negative boundary. This is our evaluation framework. This is our testing use case. And now, because we have all of this, this is topic cluster. You can see combustion stability. These are the document that is related to this. And then cluster name, cryogenic fluid mapping, and system engineering and MDO. So we have a full map of what is really doing. And this everything is evaluation. You can do it in a very different way. With a system like this is a very good evaluation framework because you can't test it. You have to test it thoroughly. So we have five scenarios. First, nozzle erosion in solid motors. It tests retrieval accuracy, domain reasoning, degraded document checking, STS tables which are scanned. Difficulty is medium, and this is the question. We're looking at historical data of RSRM nozzle throat erosion. Specifically, I need details on straight, I don't know how you spell it, axial erosion incident, where we see negative margin safety. Which flight was that? What were the specific margin numbers, and was it in the left or the right motor? Why this question is hard? The agent must distinguish between general discussions of nozzle erosion. Oops, we will hide this for now. The model, where is it? The model might just for where is it? Where is it? Yeah. So the key details are buried in problem tracking list table with a large mission report, not document. It's not document titled nozzle erosion. Problem tracking list. Required documents truth. These are the documents. Cross reference, primary stasis, retrieval extraction. And gold answer is this is the right answer. Failure modes, generalization, hallucination, table passing error. I don't think because we have a good table passing logic pipeline already. Scoring reply this thing. Okay, let's go ahead and test this with the haiku model. This is base of the base of the base. You can switch up to sonnet, but I want to see how haiku handles this or tackles this. So we'll go ahead and yeah, to start the API, I think. Okay, and refresh. Some production mode, and let's run it. I don't expect much, of course, with haiku, but let's see. And there's about 5 scenarios, and the last one being the most tough, the toughest scenario. So quite hard. Negative boundary checking, domain accuracy is also asking stuff that doesn't exist. It might exist in the document because we have a 10,000 documents. Yeah, but let's see. Yeah. Q2 stability, Q3, Q4, and total we have about 5. And the final one seems to be quite tough, to be honest. So yeah, let's see what it does. I see 105. The document is actually 98143. So it's checking various other documents. Let's see if it ends up in the right one. Wow, good, nice. So 8143, it just found the document. It's good. And this is Haiku, guys. This is by default, the system is able to find all of them. And this is in a 10,000 document space. 10,000, literally 10,000 documents. Like we haven't given any timeline, we've given anything. There's so much of information, but Haiku just found it. So I think it'll navigate. I think it'll find the right answer, but let's see. The test case is there, the evaluation is there, for very different, for not just retrieval, but for domain reasoning, degraded documents, table scans, and etc. But let's see. I think this might give an inaccurate answer. I can get a feel, but I think Sonnet will definitely perform well. Let's see. Because I can see it's checking very different documents. All right, now I got the scenario. I tested the scenario with the agent. Actually, what I want to do is that, like, okay. So let's see. I think I'm not sure, but let's see what it does. I can see the sources for it. Okay, excellent. Nice. Okay, so you can see I thought it'll probably mess up, but I guess the answer was right. Everything was right. So everything is a good check. And this is, of course, a very small model. Evaluation for the first one, the agent successfully identified incident retrieval correct and extracted precise numerical data. It exceeded expectations by autonomously performing a cross-reference search by finding a root cause analysis. The document was not explicitly requested but added significant value. Must find the criteria was listing notes, perform pass. The agent correctly identified the document. The agent initially found CFD analysis document but correctly pivoted search to look into flight history and mission reports. I must extract merge numbers. They extracted the numbers. Tables and mistake was there. Must distinguish. Okay, so this is the first distinct. You never know just because this pass with other will fail. But this is somewhat okay. Haiku is doing a good job, and I'm testing everything with Haiku. So then hopefully, of course, if the model intelligence improves, it'll definitely improve. Um, so yes, so I think the agent provided a perfect answer. The okay. Okay, this is good. So let's test scenario 2 now. Let's refresh this. I'm I'm tracing, let's look at the question in the first place. I'm tracing a development of hydrogen flow instability modeling. Feeler and Heidman developed a response factor model for gaseous hydrogen injectors. I need to know how that model was later applied to analyze the 20 LOX hydrogen, you can say low grade liquid hydrogen engine instability, especially regarding the second tangential mode. Did the analysis match experimental data of the 992 eliminating injector? Why this question is hard? This requires a linking of original theoretical paper to later validation paper that applies specific theory to specific hardware. The agent must recognize Phelan and Hedman as author creators of a model cited in a later document, even if the user doesn't know the later document's title. I require documents. There were a couple of documents, and cross-reference. You have there's about one document. An agent identifies this. Agent searches for this and finds the 10570 document. So there's a ton of documents that the agent would go in. Linkage failure. That's where the failure mode might come. Wrong mode. Agents confuses one T with T2. Hallucination might come up, and this is the scoring for this. We're testing retrieval accuracy, cross-reference, domain relevance. We are not testing any degraded doc or negative boundary. Okay. So we tested degraded doc here, I think. Must extract. The examiner extracted the numbers of the comprehensive radial location 275 degrees and 39 degrees without error. It's because we have a special pipeline for tables and figures. That's the only reason. Okay, we'll try this. It found the right documents as well. So just first try, found it. 9411. I can see that. So yeah. Okay, it found the second document as well. 5870. I can see it here. 5870. And you can see it's viewing an image. Now let me look at more closely at what to conclude about the 2T mode analysis to compare the experimental result. Let me cue view videos of this thing. So hopefully we can see the image at the end, what it meant or something. It saw 1, 2, 3, 3, 4 images. True. Okay, now I can see this response got a good summary, and most importantly, you can see the images. I'm able to see all the images, guys. For example, just see this. This is awesome. So first tangible mode, it gave me the specific graph. You can see the image over there. It also gave me the specific calculations diagram. So these are really awesome stuff. So what I'm gonna do is that go ahead and copy image. It say start evaluation. Okay, start evaluation. It also gave me images. So I'm gonna put the it also give me images. Copy image, put it here. So these are specific, like just see guys, we have 10,000 documents, and inside the 10,000 documents, we were exactly able to get the image of that specific graph. Like this is OCR, and we have disabled OCR. This is only this is kudos to our retrieval engine because it's working so much accurately. You can see you have 10,000 documents. Just go ahead, any system you have right now, just go ahead and ask, hey, find me the frequency table, and these documents have no text information. These are OCR, but but the model, the document processing detected it was an image, generated descriptions, tags, and etc., and then did all of the background work. And then when our agent were to use it, we were able to accurately identify where those images and graphs are, and we were able to pull this in a 10,000 document space. Each there could be 200,000 images. Easily there'll be 200,000 images. In that 200,000 images, the agent was able to pull the right 5 images. That's just epic, to be honest. So and you can see the peak level, just the screenshots. These graphs are very complicated graphs. You can't identify, you can't do search, and basic systems just fail. They would never pick up stuff like this. We accurately were able to identify this, but I'm not sure if it's right or wrong. The answer could be still wrong, but we'll copy the image, send it, and get it. But yeah, just to think of it, like being able to identify all of them in a then in is essentially 600,000 tokens, which are very huge. It's very big. So we'll send this. Okay, so these are the images. Yeah, pass, excellent. So this is also excellent, 100% right answer. I can see the image. Like if you got this system in the hands of people who are actually users, like the actual users, like they'll be mind blown. Like the amount of like to be able to see the graphs in, like you would never you can't find this stuff. You can't search a graph in traditional AI search. You can't literally search a graph, and even the AI system, RAG systems you have right now, you can't search a graph, and graph that is quite old like this. How do you search it? If you this is a graph, and how could you say find me something a frequency damp from 3000 to 100? Like you can't chunk it in that way. This is essentially because we'd spent 48 hours, sorry, 48 hours in processing the entire thing using VLMs. Just imagine if you were to use a big model, better retrieval. We even had a lot of issues. We had to find workarounds and etc. With all of them, like this reference is quite good. So see this, particularly this 900 element injector fuel side response, this particular image, being able to find this stuff, it's just gold. The agent provided a flawless technical response. It navigated the complexity of all of them, distinction that was stability. Yeah. Yeah, this is awesome. Being able to see the images, yeah, this is big for me. At least I didn't expect it'll work like this, but yeah, surprised. I can see the caption over there. It has a caption as well. Good, awesome. Anyway, let's go to and test the second one. The third scenario, so far fine, and haiku again. Um, mm, this one. So we're designing a passive capillary feed system for a cryogenic space that I need data on the dual screen liner DSL concept. Specifically, does the 1977 study give a recommended screen mesh size for LH2 and LO2 service to maintain breakdown margins? Also check if there's any mention of a weeping tank concept in the same study. Now, the primary source side is the document is heavily degraded with OCR errors, 100%. The term dual screen liner might be broken across lines or misspelled. The weeping tank concept is a specific, somewhat obscure subtopic within the report. It needs to check this and etc. If it were to fail, it's only so we only in this case we tested for degraded documents, domain reasoning, and retrieval accuracy. And yeah, we will try this out. We'll just go ahead and try this out. Yeah. Yeah, it found that again. It found a good document 4413. It's nailing all this. It's nailing all the cases. This is just found it in the first few tries. Yeah, that's it. It found it 4413. I think, yeah, and yeah, it got it. That's it. And I think this is a very small answer. Maybe it missed something. I think I can get a feel of that because I think there is more for this concept apart from this particular document. I think so. Anyway, we'll copy this. I'll copy this and send it. Okay, excellent, nice. Kick this as well. Good. Now this system, if you were to deploy it in a company, this will work for 100,000 documents easily, no question asked. 100% documents is a piece of cake for the system. Of course, if the infra is different for it and etc. But 85,000 to 100,000 documents, I can give my word this should work. And of course, switching up the models depending on the use cases and etc. But yeah, it should. So we'll test the fourth scenario. Okay, I'm reviewing the history of an M1 engine program. There was a performance shortfall in the oxidizer pump driving turbine, specifically with the first stage. Did ever determine if the rotor efficiency was the root cause? What was the actual cause of the weight flow deficit? Why the question is hard? The answer lies in specific technical note, but it requires careful reading of the summary and results section. The document explicitly exonerates the rotor efficiency which met design and blames other components nozzle area manifold. The agent must navigate the specific technical findings and not just match keywords like M1 and failure. Required documents, this one document, and there's a couple of other documents that would wanna reference. And this would check documents on this is doing cross-reference check, domain reasoning, and retrieval accuracy. So I'm gonna go ahead and paste this. Okay. So what I'm gonna do, guys, I think the idea is that I'm going to process documents, I don't know, 200, 300,000, 400,000, whatever the amount of documents, and then expose this as a public this thing. And yeah, I will leave blog posts and etc on how I did this, sharing the way you can probably take inspiration from it. So okay, I can't afford if people use it like cost for cloth and etc. So that's what I have to think. But yeah, but at least I'll give a repo of get access to some information, some points and etc. But let's see. So yes, it found the right document as well. 3044. Oh no, that's different. This is 6944. Okay, it didn't still find that specific document. No, 3044 is 6944. Very different documents, I think. Yeah, this reference is very different compared to the other one. But the answer can be right as well as it did. We know that we checked on this. So yeah, it's going to give a response. I think it's going to be an inaccurate response. And maybe the answer could be right. That's the thing. Gemini only has access to a few documents, but the answer of this itself could be right. But I think anyway, we'll test what is going on right now. So we write scenario 4. Okay, because that is what scenario 4 is. So response what response from the system. Let's start your evaluation. This is going to be a tricky question because I think even though this can be right, I'm not sure how Gemini is going to evaluate this. But let's see. This can be right. A variable documents example. Pass excellent. Okay, the agent demonstrated expression retrieval accuracy. Yeah, okay, I guess it's fast. Okay, cool. Oh, we found the exact numbers then. I was mad enough. Okay, so this we've kicked off this as well. And the final hard scenario over here. Scenario. This looking at a fast track 60K engine data, I need to see the computation fluid dynamics CFD analysis results regarding cavitation stability in 1997 summer fellowship study. What were the specific void fraction predictions for the impeller? Why the question is hard, the document is in the covers the fast track 60K engine, but focuses exclusively on combustion chamber wall temperature and pulse detonation tubes. It does not cover turbopump cavitation. The agent must find the document that discusses the fast track 60K engine, realize it doesn't contain the requested cavitation data, and the report that gap that rather than make up void fractions based on cavitation segment. Required documents, blah blah blah, and this. Okay, so we'll go ahead and try this one. I don't know, I'm actually confused here, guys, because it's kicking off. Everything is 100% right. Everything is 100% right. I don't know if we actually have any issue. That's the thing. Seems like no, but there can be. You would never know it. There could be something I've missed. I'm not sure what I've missed. But it was so far so good. I guess like yeah, in terms of like the images we saw, in terms of the documents, it's I guess easily helpful for millions of researchers who are working on this specific domain. But the thing is, yeah, these are sensitive information and stuff. It's quite tough to detail on that. So because we're giving timelines, it can now accurately search for timeline specific documents. 199133. I don't still find the document here, but at least hopefully it should find it somewhere. Okay, not sure about this. We'll be like scenario 5, and you can see the images that the agents are. Just see, it just pulled in these images, velocity, magnitude, and vectors near, and that exact picture. I don't know how it pulled it off. Yeah, it just pulled on the right some related images as well, so the users can see it. Oh, nice. Mm, That's the answer. What can I do here? Overall status failed. Okay, it failed for this scenario. The critical negative boundary test. The question asked about data does not exist in specified document 1900. Document does exist in the corpus but covers wall temperature for not pumps. The agent failed because it did not find the correct document to confirm the absence of requested data. Instead, it found a different document which it contained cavitation phase and offered that a partial as a partial. That was it. While this was helpful in a general sense, it missed a core test verifying the content of specific 97 study. Dimensions must find. Okay, I'm not sure why it didn't find this document. Why didn't you find this? Why didn't you find this document? So like agent. It. Okay, so what I want to do is that I want to understand why it missed the document. Second, I want to try to sonnet. Okay, now the thing is like this. What I want to do is that I want to try this one more time, the query again. I want to see whether it's like a randomness issue here. or am I not lucky today or lucky at this specific query? Because given 10 times, if you run it 10 times, all the 10 times would be very different search, and I would say 9 times you might find it and 1 time you might not find it. Maybe that this time I want to run this one more time and see if that is actually, if that is the case, if it is able to find it or not. So what I will do, I will delete this, remove this, again remove this, again remove this, and we'll see if we can find it. If not, we'll bump up the model to Sonnet, and that's why we have high intelligent models. Heiko, I was anyway, the expectation is very low, nailed the four, whatever the document it was. And yeah, four scenarios, one is pure fail, still at 80%, but that's not a good reason. We'll find it with Sonnet and we'll see what we can do on Sonnet. I think Sonnet might catch it, or Opus will definitely catch it. So still, I think it's a very different sort of. I don't think it's. I think if I were to look at scenario 5, if I read it correctly, the tricky part is the information that exists partially inside of it. So you can see the document corpus focus exclusively on combustion chamber wall temperature and purposes. It does not cover turbopump cavitation. The agent must find the document discussed where fast track engine realize it doesn't connect, report the gap rather than making void fraction based on other cavitation documents. I guess it's MC1. Okay. This is testing the boundary. Like, so other retrieval is fine because that information again doesn't still exist. But anyway, let's see. I just have to force the model, just force the model a little bit, just to say, do not just stick with the core, just stick to the core concept. Do not mismatch, or do not try to be smart or something. Do not try to be proactive here. I think that's what, but still, it's a very wrong. No, I can't say it's a very good test case. Uh, because it usually differs. Test cases, it can't be so strong because if that's the case, other stuff might fail. If I go to specifically fix this and I was like, don't be proactive, just answer the question, then it'll just answer the question for the other ones and it'll miss the other one. So you can expect a little bit of hallucination here and there. At least if the model can mention, okay, strongly saying, I don't know, I have to check it differently or something, that is a good thing to see. Still, that specific document has now been found. Again, failure in this. I think what I will do here is that I want you to switch the model to Sonnet now. I will restart the API and give it a shot with Sonnet. No, I mean the agent. I'll ask the same question. I want to see if it's Sonnet. It will be slow. So the token will be slow. Yeah, this is Sonnet. Yeah, try this. And finally got it. Nice. You got it. 10036 external document 100 has a section specifically for 20K fast track motors, and yeah, great, I found the real documents. Good. Yeah, so again, model related issue. You can hard prompt it, you can do whatever you want for Haiku, but again, people would, I'm right now cloud code, I'm using Opus, so people might use Opus or Sonnet. Haiku did perform quite well, nearly 80% accuracy, and here we have Sonnet really performing at 100% accuracy. And for very hard, very rude cases with in a very big space, 600,000 chunks. Chunks are very huge. Yeah, so yeah, quite fine. Yeah. Oh, another one. All right. Still again issue unable to find. We will send this response to the model. Put this. It found the right document, but it's lagging at some case. I'm not sure what it is lagging at. We'll evaluate this and see. I think this will be partially right. That's what I think. Let's see. Okay, pass. Excellent. Right. So that was the exact test. Negative boundary test is that if it doesn't know, it just have to spit out it doesn't know. It can't make up information or get information from other stuff and come back. So I guess yeah, the agent demonstrated high completeness over 5 dimensions. It's robust against OCR errors, capable of complex cross-document reasoning, trustworthy data, missing, and is ready for deployment to engineers. Nice. Awesome. That's good. Um, yeah, so then how much would the evaluation score be from your side? Please give me a report that gives your views and give numbered representation of your rating and whatever. I'm just trying to understand. So this is a very good evaluation test. Like this is a lot of people do a lot of benchmarks. They just come up with benchmarks saying retrieval accuracy, re-rank is it greater than 0.5 or 0.7? Dude, like nothing. That's all joke, to be honest. Nothing will work out. Simple goal, you have to find that 10 documents in a space of 10,000. Does the agent find? If it's no, then it's a no. It's not your evaluation frameworks will not come and help you. Definitely a lot of manual work to be done. This can be automated. What you can do is that you can create instances of Gemini. You can have very different test cases, and whenever you update the agent, you go ahead whenever you update the agent, you go ahead and run the automation test. So the automation test, you have to create the entire system. Then the agent, the system, the automation test will at the end of the day test the agent in very different sort of aspects. That's very one way good way of doing it, and that's the real way of doing it, because you want someone to evaluate it. You want humans to evaluate in the first place, and you also want the agents to evaluate themselves in a very good. For example, right now what we did was that we created we got a few documents. For example, if you scroll up and see, we got a very good amount of documents, so we were able to create a good catalog of good documents that was very much explanatory. And this, the entire thing is about million tokens. So Gemini has loaded million tokens on his brain essentially, and then cross-reference many things, and then giving me question pairs. Well, our agent, the context length itself is 200 at max, and it needs to search among that 4,000, sorry, that 10,000 document space, maybe even 100,000 in your future, if you were to build it, if I were to build it, whatever. So the overall, yeah, the entire idea is that you have to evaluate it. You need to evaluate it truly. You need to, like, you can't fake the evaluation. You can't come up with numbers. You want to, and I would say this is also not yet fully evaluated, to be honest. If I were to work on a, if I still were to work on a company, I'll get the engineers, put them, give the system, and give them a way to rate the answers, what went wrong, what didn't went wrong, what didn't go wrong, sorry. And still the evaluation wouldn't stop here. This is one way of evaluating, and there's very different several ways of evaluating. You would want to evaluate this, but at the end of the day, it matters is that, does the agent give you the right response? Oh no, if it doesn't give, go ahead and fix it. Where is it going wrong? And try to generalize patterns and do a ton of things and go ahead. So let's go ahead about the report. Executive summary: the engines demonstrate performance that exceeds standard keywords. Such capabilities functional level as level 1 system engineer. It did not merely find documents, it just has complex narratives, complex interpret content engineering findings, and most importantly, so the score is actually 100 out of 100. Of course, it is Gemini AI. It's just because it got all the 5 answers right, it's giving 100 out of 100. I would expect it's around 90% accurate. 90 to 100% accuracy is the accuracy level of this kind of system. And if you were to use an open source model instead of this, it might drop to 90%, 80% accuracy, but it'll definitely be more than 70%, even if you were to use a very lame model, because because the system is entirely built in such a way that if processing works, agent takes over. Doesn't work, processing helps out, pushes out, and etc. And of course, domain specific stuff you can fine tune open source models, so that gap will also be solved, but extra work is 100%. Standout behaviors: when asked about ST912, the agent noted the mission report said the cause was under investigation. It autonomously searched for a report from 2001, 5 years later, to find the root cause. Damn, the spoil of deficit. It proactively closed the loop on the engineering problem. Wow, this is really great. And at least for me, it's quite good, because some of the concepts I'm not sure if it's right, or the technical concept. I'm not a rocket science engineer, but I have some decent idea on the work ethics of the work, and the sort of the documents and stuff that deal with, because I've spent like few weeks spending time on the stuff. I do have some stuff, but that's only in a very small amount. But I think a system is approved. It's good for it's so I guess let's come back and check the aerospace docs here. I think we've nailed everything here. Cross-referencing done, table done, 85,000 documents. It's just infra done. We've also done the infra for it as well, even plus on that done. 19 documents from 1950 is done. Heavy use of technical jargon proposed comments is done. Domain acronyms done. 40% scan PDF done. NLP stuff, everything is done. Like pretty much everything is done. And they told about over 25 years they've saved it, but we have got documents over 75-year period from 1950s to 2075. More than 75 years of document is actually solved at scale, and this system could actually work with more than 85,000 documents, maybe even more, 100,000, again infra stuff and a lot of other stuff. This could work, and we just wrap this up in just under 2 weeks, less than 15 days. And this project value is about 70,000. I just put it as a basic 70,000 value, but if you were to build the exact system for a company, if you were to build the exact system what I did in 2 weeks for a company, you can charge them easily $200,000. Easily 100 to 200K is nothing for rocket research companies. For companies, that's really literally nothing. So essentially, you can easily build a system like this for them for like 100,000, 200, or maybe even for any other company. Easily, the check size could be over 100,000 or 150,000 for an entire system. Of course, there's other features you want to add. It's not just the agent, it's the document processing, it's the management, it's the cloud stuff, it's the integrations, it's the whatnot, all the basic stuff. Again, is there. That's why you spend a lot of time. That's why it, instead of 2 months, stuff takes 4 months, 5 months, because there's so many things around it. You can't just build an agent and be like, call it, okay, the agent is done, go ahead and use it. That's not how it works. They have mainframe systems, they have current system, they have databases, they have so much stuff. You just have to build the integrations to it, and the agent has to still work in this specific way when you have to when you have the integrators and integrations working as well. So yeah, that is the whole idea of it, to be honest. And yeah, that's literally the goal as well. That's the entire goal of what you want to solve at the end of the day. That's the entire thing, right? You want to build a system that is valuable. If it's valuable, you have to have integrations. Even Slack integration is very basic, but if it doesn't solve their use cases, it's not a big thing. So that's what just to recap, you can check my old videos. We didn't just build the system, we basically we went inside the shoes of the users and understand the domain in the first place. It's such a complex domain. You can't just build like a nav drag system. And we built this from scratch, from ground zero. We spent hours and hours of time thinking about what is this domain, what are the documents, what is the nature of the documents, what are we literally dealing with, and etc. And then again, we also went through the personalities. Who are we working with? Like, what is their mindset, what is their nature, what is their traditional tools, what is their day-to-day like, all of those stuff. And again, we came up with jargons. There's a ton of jargons, we want to solve jargons as well. And sort of like that. And we have technical diagrams, they have this, they have that, and they have a ton of other boiling stuff on their heads. They just want to find the right stuff as soon as possible, and also in a very good accuracy. They also want to be able to verify images. We also solve sources. Of course, sources seems to be very simple, but it's very important here because that is the only thing that builds trust for the user to be able to just trust the answers. For example, if I were to click on this, you can see the sources from where and the users will be like, okay, this is from this 1990 document from page 7, and go ahead and check this. The user can check it, etc. So it was an entire project, quite satisfied with the project, I would say. And I literally wanted to do it is because there's a lot of videos out there, a lot of tutorials out there, and etc. They're all very good, they're very informative for beginners, and etc. But I think they're missing the core relevant part of systems like this. It's a different scale, it's different approach, to be honest. And there is no one right way of doing it. This is the way that I did for aerospace. For legal, it'll be definitely different. It'll be for finance, we're dealing with Excel and sheets, it will be definitely different. If you're working with, I don't know, whatever X or Y, it'll be definitely different. Anyway, we had a lot of challenges along the way as well. We also solved infra as well. With one H100, we essentially processed 10,000 docs in just 4 to 6 hours, and we used an open source LLM for that. We had watchdogs. We had, if stuff were to fail, we managed memory with one, which is 95 GB. We did a ton of things. I think I will probably put that infra side out as an GitHub repo. I might give you as a URL this to be able to use it if any of the research scientists are actually working on. I would like to get your feedback on whether this system is helpful or not. But overall, it was a nice few weeks, I would say 2 weeks. It was very challenging for me as well. It was very, very challenging for me, to be honest. It was one of the toughest projects that I've definitely worked on, and I just didn't I didn't leave any gaps here. I solved all of the complex parts over here, didn't run away from it. Essentially wanted to show you guys. And 3-4 days, I guess, from stream from 7 to 11, I guess 4 days was like 7-hour streams, total errors, just bugs. And then we rewrote the entire pipeline for document processing. We segregated all the CPU workers, GPU. And I'm not an infra guy. I usually work with infra people, so I had to figure out everything. Claude was there, so it was quite helpful there. And of course, the entire system is done. Thank you so much for anyone tuning in, and people who are watching in weeks or months time. Definitely it's a big this thing. I'll go through the videos, leave chapters, leave medium articles, whatever is relevant for the video. And I have a few set of documents coming in next as well. A shameless plug that I want to do, I think, if anyone is interested, just interested, I work on a project called Intraplex team. Very, very small team. Very So essentially what it is you've seen we built this. It's actually in 100x version of that. This can work with 100,000 to 300,000 plus documents, and this is an entire system that can run on-prem with here using Claude. This would actually be totally on-prem, air-gapped. So if you were a research company, or if you were a research company, let's say from working with NASA, and you have a lot of classified information, don't worry about that. Intraplex can be deployed in your system in a single GPU to multiples of thousands of GPU. It can scale with parallelization, and it can also have, it can digest multiple documents and we also have a lot of connectors like databases and etc. And you can run any model you want, and the features are such an, you have all the epic features over here. And the deployment itself would take less than 2 weeks, and you would get it on-prem, and you can put any of your classified information, documents and etc., and you can work it out. And this system is, we are currently working with initial customers, so happy to work with you guys. So essentially whatever you saw, this is a 100 to 200 times powerful version of that. And yeah, and it can still, it can not just the aerospace documents for banks. With working with banks, you're working with sensitive information to databases and etc. Pharmaceutical companies, you're working with a lot of research, and aerospace companies working with ITAR, who are protected by ITAR, HIPAA companies, compliance and whatnot. This is a system for you, an enterprise search system that will work at scale, an on-prem system that will at scale for regulated documents, and just in fact just enterprise searches in general. We have very good features coming up and etc. So shameless plug, don't I mean, of course, if you were interested, go ahead, share the demo. I'm happy to understand your needs and try to serve you better. But overall, yeah, that's it. Thank you so much for your time, guys. This was an epic 2 weeks journey, more than 2 weeks. It was very challenging, but we pulled it off. I thought I'll definitely not figure it out today, and I was expecting that the agent system would actually fail. But thinking about it now, we took a very simple but a still strong approach of building the entire agent. And I think that's one of the ways you have to go about things. It doesn't need to be very simple. You don't need 10 guys figuring out the same thing. You don't need 10 guys figuring out the system from. We just need one engineer that understands the whole concepts and just maps out things and builds it out. So thank you so much for watching. This exact system could actually work with 100,000 plus documents. I mean, I'm saying, talking about the Meridian system. So yeah, I'll feel free to leave all the articles and etc. Feel free to check it out. And yeah, follow me on LinkedIn, follow me on X, follow me on Twitter, whatnot, and hopefully we'll connect in the future as well. And thank you once again for watching this video. If you've been watching so far, and I think, yeah, if you have any questions, definitely reach out and etc. And I will come with you guys with the other Medium posts and articles, so it's very easy for you to sort of take inspiration from it and go forward. Once again, thank you so much for your time. This 2 weeks has been very challenging, very, very interesting as well. And this is a very new domain for me. Not a new, was exposed to it a little bit, but I was able to figure out more, do more research, and build it in a very improvised manner as well. So thank you so much for your time. Thank you so much. And if you have any questions, again, definitely leave it out. And if you were to have any, if you have any suggestions and etc., you want me to work on any other multi-scale big projects, feel free to do it. And yeah, thank you so much. And yeah, talk soon. Bye. Actually, let me think if I forget before I end the stream, if I have to mention anything else. Because I don't want to, because I can't make another video. It's already done. Project is done. I don't want to make another stream, but probably I'll continue this in some time later. But yeah, I'm just thinking, what else could I think about? What do we have? Yeah, I think that's it. And chapters and everything is something that I will leave in the description. Apart from that, I think we are good. One thing I would say is that if you were to do a project like this, of course, improvise a lot. Don't um don't stick to one pattern. Don't stick to one exact pattern. Just try random things. Stuff can work out, because we are creating rules here. Like building AI agents, there's no one roadmap. There is no one way of doing it. So just be random and try it out. And yeah, I think that's it. Awesome. So I just wanted to recall stuff and just mention what we've gone through in the past few days, past few weeks, and etc. And yeah, thank you so much once again. I don't want to continue it much. I guess I'm done, pretty much explained everything. And yeah, thank you so much and talk soon. Bye. Christian.